This is AP Calculus Lesson 8-2, Understanding Total Change. All right, so today's date is January 23rd. It is a Wednesday. So it's the same example as 8-1. Example 1 and example 2 on the back are the same examples. I did fix this one. All right, so we don't need to reread it. We know that it is filling a can. We actually say the rate instead of the rain at which. All those typos have been fixed. So, same problem. Let's take a look at that graph again. So this is a nice graph provided by Desmos. Thank you. The calculator one is way too hard to write on. So, if I'm looking at this graph, again, the way that we write an integral is really just saying we are taking a little tiny bar here, and I'm going to use technology to make sure I have a nice straight bar. And you should do this on your notes as well. So if I have this little slice of the graph, this slice doesn't perfectly match. In fact, let me make sure it perfectly does not match. We have this little slice, this little bar that will approximate this area underneath the curve. If I infinitely add those, that's the same thing as the integral. If I just have a bunch of these bars and they're pretty big, that's called a Riemann sum. We don't really get into it very much in this class, although we could if it was a normal non-AP class. Where the derivative, or the origins of the derivative, I should say. So if I take a look at this bar, let's go ahead and analyze the units of this bar. Again, integral just means we're finding area. So if I look at that bar again, let's go ahead and draw this bar down here. Here's that same bar. Do an arrow. That's the same bar. In this problem, we had, it was supposed to be millimeters, not milliliters, so that was the other typo that I caught on my own. We have millimeters in terms of how much we have, so millimeters were on the side. And then we have how many days were in this 60-day period, so this is a unit of days. And since this is actually a graph of S prime, what should our units be over here, class?
Yeah.
It is millimeters per day. And for some reason, oh my gosh, I know what happened. I had the equation here, and it dropped it into the next line, which is behind this graph, which is really dumb. But we will need that equation because we need it for our calculator. So let me come back and find what that equation is. Sorry about that. Actually, can you look at your notes from yesterday? Do you have that in your binder easily accessible? Notes 8-1.
2 sine.
0.3t. Yeah, there it is. Okay. So I think we need to rewrite that on our notes. Oops, what am I doing here? So write down 2 sine of 0.03t. Just always have to have an error there. All right, so it's millimeters per day, which means let's go ahead and label this bar. This bar has the same units as the graph. So this unit on the bottom is day, this unit on the side is millimeters per day, and therefore when we integrate this, we get what? When we find the area of this bar, we get a units of millimeters. So when, yeah, you're just multiplying units, you just multiply, it's going to be millimeters per day, and we multiply that with day per 1 if you want to have a fraction, or just times day. Days cancel out and we're left with just millimeters. That means one really important thing. When I integrate rate, I go back to just counting the total number of basic units. So if I integrate rates of millimeters per day, I'm counting the total number of millimeters that happened between whatever my bounds of my integral were. If my bounds were from 0 to 30, I'm finding the area between 0 and 30, which means I'm counting the number of millimeters that have collected between times 0 days and 30 days. Nod our heads, we're good so far? All right. So, moving on. This is an actual question that you will see on the pretest, the test, the fix-up, the self-check. Explain the meaning of an integral. I guarantee you will, well, I can't guarantee it. There's like a good 90% chance you will see this exact question with a different integral and different context on the actual AP test. Explain the meaning of this thing? Who wants to take a shot at it? Explain the meaning of this thing in regards to the question. I basically gave you the outline of what it means to take the integral of a rate. Can you guys regurgitate it to me in the context of the problem?
Would that be the total change in the level of the rainwater from 0 to 30?
0 to 30 unit days. There it is. Beautiful. I'm going to basically rewrite almost exactly what Ben said. So it's this thing is, or it means, if whatever you want to write here, I'm going to say means. This thing means it's the total change. In the height of the water. And then we'll put in parentheses here, in millimeters. Always include the units whenever you're explaining something. So if I'm explaining the meaning of this, we're going to say in millimeters. And then from where to where? From 0 to 30. So from 0 to 30. And again, use units, days. Usually this question is phrased, oh yeah, it actually is phrased correct because using correct units. So we have our units for both what we're counting and our bounds of what we're counting. Make sure you have the units. So here are the key things that you should be underlining. You need to say total change, and you need to say units, range. Those are the key parts of what we wrote here. Units, unit, range, and total change. If you have those 4 components in your answer on the self-checks, on the pretest test, all that stuff, the actual AP test, you will get full points for this. This is usually a 2-point question. You have to say...
Can you just say total change in millimeters from 0 to 3 days?
Yep. If you just say that little blurb, you get full points. You just have to memorize those. This is the full English sentence that sounds great when we are talking to Miss Taylor, but yes, you can abbreviate it and just say total change in millimeters from 0 to 30 days. Although it is better if you explain in the context better height of the water, but I don't think you need it. I'm like 95% sure you don't have to say that. All right, let's do B. How many millimeters has the height of water increased from 0 to 30 days? So now I'm trying to find that total change. What is that total change? Well, luckily we defined that the total change is from 0 to 30, that integral. So let's calculate the integral from 0 to 30 of s prime of t. How am I going to do that? With my calculator. Tell me my steps. Get out your calculators. You're already on it? Are you going ahead of me? 2 sine 0.03x. So first, enter in your equation. Does everyone have the correct equation? It's 0.03x on the inside of 2 sine. What is our window going to be?
0 to 30.
0 to 30 will work, although technically the problem is 0 to 60 because it's during a 60-day period. Either way will work. I'm going to do 0 to 60 because that's the entire context of the problem. And then once I have my window set, what do I do in order to correctly zoom to the graph?
Zoom 0.
Zoom 0. It's loading, and it should hopefully look like this graph here. And it does. Okay, so there's the graph. Once I have the graph, then what do I do? What next? What are my next steps? Second calc 7. We're calculating the integral between 0, enter, 30, enter. And we're going to say this is approximately, because we are rounding now, 22.226 or 25.226.
I got 25.23.
Really? Interesting.
This calculator must be rounding to another. Oh yeah, it's only set to 2 places float. I'll just set to 3.
Nice. I was about to explain that, but you already know that. So for those of you that didn't know, if I'm at my graph and it got some weird number, you go to mode, and then you can say float, so it goes forever, Well, I guess not forever. I don't actually know how many float is. Or you can change to how many numbers it rounds to. Right there. And for almost everything in AP Calculus, it's in radians. But for Rochelle, who's also in pre-calculus, we do some things in degrees. She knows how to change that. Cool. What is the second way of doing this integral without a graph? Do you guys remember? It's a faster way of doing it. Because as soon as you do y equals, you don't even have to do a window. You don't have to do a zoom. You don't have to wait for it to graph. You just immediately, after y equals, you go second quit and then do what? Do you remember?
Math.
Math, yes. Math, which of these? 8 or 9? Is it the derivative or the integral?
Integral.
Integral, so it's math 9. Math 9, the integral of my y1 function. Do you remember how to get to y1?
Wasn't it the bars and then go to right? Enter.
y1, yep. And then it's with respect to x, yep, from
30.
so from 0 to 30. Perfect. That is the second way of finding it. It's way faster, 25.226. I get the same answer. There are 2 ways of doing it. You can choose whatever floats your boat or sinks your sub. Let's go on to the second example. Oh, yeah.
Forgot your units.
Oh my God! It didn't say mention units, so I wouldn't have lost a point. But if it did say mention units, you should always just assume that's mentioning units. Definitely mention those units. So what are they?
Millimeters. Or just millimeters.
It is just millimeters, yep. Because we already analyzed up here that it should be in millimeters. Perfect. Yeah, as a rule, just try to always mention units. You can't lose points that way, although you wouldn't have technically lost a point there. But good, Rochelle, you keep me on my toes. I like that. So, example 2, same problem as before with correct numbers. So, let's go ahead and just revisit this. We have people entering at this rate, people leaving at this rate, and it's valid between 9 and 23 hours because that's the time when the park is open. The question now, how many people enter the park during the first 4 hours? What are we really calculating here? Symbolically, write down the symbolic representation. It is a point on the AP test. What is the symbolic representation of what we're doing? It's very similar to what we just did.
Would it be integral of e of t?
Integral of e of t, yep.
0 to 4.
dt from 0 to 4? Not quite. Because our bound should start at 9.
Alright.
It would be 4 to 9?
No, it should start, 9 to 13. There it is, arrow. 9 to 13. Those are the first 4 hours in which the park is open. All right, so this is what we're going to be finding. So we can do this graphically or fast. I don't know what you prefer. So I'm going to set my y1 equal to my e of t function. So 8600 divided by, start my parentheses, it's going to be x squared minus 25x plus 163. And my y2 function, I'm going to set that to 9890 divided by, start my parentheses, x squared minus 38x plus 370. All right. Do you guys prefer graphically or do you prefer the symbolic on the calculator? Graphically, Rochelle? Let's do it graphically. My window is going to be set between 9, enter, 23, enter, because those are my bounds, and I'm going to hit zoom 0. And you can see the loading bar again. We're waiting. And hey, the graph actually looks like it's supposed to this time. It's really satisfying. All right, so let's see here. I'm trying to find the integral, so I'm going to do, Ben did the steps last time, someone do the steps this time. Either Arrow or Rochelle. What am I going to do? I'm finding the entering equation, which is this first loop. How do I do that? How do I find the integral of the area between 9 and 14? Or 9 and 13, sorry.
So you go to second trace.
Second trace, 7.
And then you go from 9.
And make sure you're on this y1 function first, right?
Oh.
So you might have to hit up or down. I'm on y1, it says it at the very top, I'm on y1, and then I say, yep, 9, enter, 13, enter, and it should shade our first function right there. And I got 3,715, 3,715.
Because it talks about people, do you add the decimal?
That's a great question. What do you guys think? What would be your best idea if you're talking about an AP test in the context of the problem? We're talking about people entering a park. Should I do 315.177 or 178, or should I just do 300 or 3,715? Should I have a decimal? Should I not?
I always feel comfortable with adding decimals.
You feel comfortable cutting up body parts to make sure we got exactly 0.1778
Yes.
of a person? What is that? Is that like a leg, or is it an arm? Is it just a wrist and a knee?
Could be a ear.
I think we're going to need a little bit more than an ear to get 17% of a person. Generally speaking, you need to round to the nearest whole number when you're talking about people for the AP test. Let's keep whole people. I don't feel like cutting up people today. Unless you maybe want to consider a baby like not a whole person,
Let's just be the Texas
then you don't have to cut
Or
up
like
people.
the 3/5 compromise.
You are worth 3/5 of a person.
Let's just be the Texas
You
Chainsaw
slave.
for once,
No.
We're going to go ahead and say 3,715 people.
But wait, the middle-aged husbands that don't really want to be there, that were just dragged there by their kids and their wife, are like 3/5 of a person, right?
Because they're enslaved to coming to the.
Basically, yeah.
Okay, I can kind of see that if we had the 3/5 compromise still.
There's-
All right.
And that's probably like 50% of the people there.
Yeah. And what do
don't
you?
want to be there.
What if like literally half of you is missing? What if like war? Okay, maybe we're getting into too much.
What if
Okay.
our
Yeah.
soul is in there, you know?
What if our
soul is
soul?
body.
What if we have a bunch of Horcruxes elsewhere? Do you still count as a whole person? I don't know.
Or if
What
they're
if
just
like you
ghosts
have
in
like
the
your body
movies,
parts,
like-
like what if you have your arm? What if you have your arm, but you have like those metal ones, and you just throw it in the park? There you go.
Gross. Okay.
Okay.
What am I asking for part B? I gave too much away already. What am I asking for symbolically for part B? You do need to write this down for the pre-test test self-checks.
The derivative. That's what it's called, right?
Nope.
That's the
Integral between where and where?
9 and 13
9 and 13 of
LT.
LT now. LT dt. All right, let's calculate that on our calculators. So now we're looking at this second curve right here. So I'm going to screenshot this to just put it in the notes because it looks cool. Technology is really cool. Boom. And paste that in here. Ooh, that's too big. And then now I'm doing, I'm going to zoom 0 just to make my notes look better. Because otherwise it'll have the other section shaded, and I only want the first, I only want my section shaded. So you don't have to regraph this. I'm doing it to make it look nice for the notes. I'm going to do second, trace, 7. Make sure you're on the correct one. So I'm going to hit down to go to Y2. Once I'm on Y2, I hit lower limit of 9, enter, 13, enter. And it should shade that section, which you can't really see on yours, but I can see on mine. And I got 567.655. Did you get the same thing?
Yeah.
So what should we round to?
568 people.
Yep.
I think you should round down to 567.
Ooh, that's a good question. Should we round up or should we round down?
You know what? Just round down.
Round up. There
Round down.
might be ghosts.
I think round down, because if you have, like, you can't have we've decided you can't have a portion of a person. And if you don't have a portion of a person, then
Well, yeah,
That person
because-
hasn't fully
by
come there yet.
rounding up, you're basically creating a person that doesn't exist.
Well, like, what if there's a pregnant woman?
We're going back to that debate.
Then you round up because there's.
I think you can argue either way. I'm persuaded by Ben's logic to do 567. I don't know if there's a right answer here. Usually AP tests are designed in a way that makes it come out nice, but if it's not, it's up to you.
But I think these equations are probably for the purpose of park officials to see how many people are paying admission and coming in that way.
Which means that,
So
like, an unborn baby doesn't count
Yeah.
because it's not paying admission.
Okay. So really making it a real life problem.
and also it wouldn't make sense to round up because they don't want to create a person in their figures that didn't actually exist
Yeah,
and
but
pay
what
admission.
do you care about one person if they actually existed? It's like a small enough error that doesn't
But if it's really easy to avoid the error, you probably would.
All right. So, and finally, part C. What am I asking for? You always need to write down the symbolic notation. They give you 1 to 2 points for just writing that down. Yes, Risha?
The integral of 9 and 13
Of?
of LT?
I think it's E first.
I don't know. I get confused on which one's
So entering, that's the positive one, that's the negative one.
So should it be a positive and a negative? So it'd be E of t minus L of t
That's correct.
dt.
And then all of that in parentheses, dt. Yep.
How do you know which one's supposed to go first?
That's a great question, and it's a hard question to answer. Well, not always a hard question, but usually it's based on the context of the problem. ET goes first because that's the positive. I'm entering, so I'm adding people. Adding is positive. Leaving means I'm subtracting people. Subtracting is negative. I'm subtracting people because they're leaving the park. This integral calculates how many people are, well, just what's changing in the positive direction. You could say LT minus ET, and that represents how many are leaving. So if that number is positive, that means I have a negative amount happening to the park. But usually you always want to think about it in terms of the positive direction, ET minus LT.
What if they're both negative?
What if ET and LT were both negative, like these
So
graphs were
like,
both negative?
What if this is basically comparing two amusement parks? That and comparing their how many people leave?
It would be a different question. Because you don't have enough information.
Yeah, I think you need a ton of information, and that's too complicated for what our task is today, or for just the AP test. They're not going to ask you something so complicated. Yeah, but that would be a fun question to answer because you get to analyze different parts.
Complicated.
It's fun. And I should have been this whole time. I don't like writing equal signs when it's not equal. It should have been approximately equal to on these guys. All right, so what is our answer here? And you can do it a few different ways. I can do the exact answer by doing this. I can do second enter my y1 function between 9, 14, and then I can do that one, subtract math 9 of y2. Oh, 13, thank you. Teacher error. 13, and it's going to be var's right, enter 2 with respect to x from the same bounds, 9 to 13. So I can do one minus the other, and I hit enter, and I should get the right answer, perfectly right because it's stored, which makes sense. 3,700 minus about 500, 600, 560, I don't know what I'm saying, is about 3,100. And I got about 3,100, 3,147, 3,147 people. And we're not going to round up, we're just going to cut it off, truncate it, and say that many people.
What if you just do 3,715
Um,
Does that not work?
that
you get
feel like that works.
3,148.
No. 3,147.
no, that's a really good math question. So assuming that you've always truncated, you haven't rounded, you've just cut off the decimal, will you ever get a wrong answer when you're doing one minus the other?
I just feel like
It's
that's
less
just too
accurate, but it
complicated.
shouldn't matter. But it probably does.
So I'm trying to think, how can you get a wrong answer? You could get a wrong answer if you somehow rounded this one up, which you never do. You always truncate. So I think this one will always be, okay, here's where you could get into trouble. If this one was 3,715.2 and this one was 0.3, when I do this one minus this one, it'll actually go down farther than it should. This could have been 3,146. You might be off by 1. So you do need to actually look at the decimals.
Hey!
So you just write the no.
You need at least one decimal when you're doing the calculations, or you can do it exactly like I did.
Can I just have like the whole like say like for the first one, like it was like 3715.156. Can I just put it to the side and then right when I go to the last question, just do the whole thing, subtract it to whatever I got from LT?
Yeah, and then for part A, box the rounded answer. Yep, and that's a really good a way to do that too, because sometimes the way the AP graders do things, because they're in such a hurry, is you write 3,715.178, and then you box this one. You're more likely to get it correct just by having a lot of numbers. I know it's a cheesy way of doing it. Usually AP graders are pretty good about saying, okay, like I can clearly say they're doing things. If you just write a bunch of random numbers hoping you get it correct, they're obviously not going to give you points. But if I wrote these two things, I don't know why I wrote a 7 there, that should have been a 5. But if you wrote the decimal and then you rounded the answer, they can clearly see that you knew what you were doing. And then it was your philosophy that made you not round up. It was your logic. All right, that is it for the notes. Are there any questions? Cool, go ahead and write your summaries and then you can begin on the homework.